No, I've been sleeping ever since we crossed over into Quebec, but I find myself now on the Gatineaus. Beautiful hilly area on the western edge of Quebec. Very, very rich in minerals. Distinctly different in many ways from Ontario. Yes, they still have the mica mines that Ontario had, or has, but I mean there's some very, very different minerals. For example, we've got the tourmaline at the Leduc mine. We've got what else? We're going for spinel. We're doing spinel probably later today. Tomorrow we're up here for the night. So we'll be looking for spinel. There's blue apatite, which is a big rarity in Ontario. That's just a couple of the things that is unique to the Quebec rock and mineral scene, and all that it took was just to be on the other side of the Ottawa River. And of course the geology is a little different too. We've got the hills here. We're basically separated from Ontario not only by the river but also by the Ottawa Bonnechere Graben, which is a faulting area. It's where the ground drops between two geological faults. Graben being the German word for coffin. So yes, they are indeed earth tremors here from time to time. One of the things Jeff has recommended to me recently, the movie Hangover. And this, what was the scene with the tiger? They found a tiger in the bathroom or something. It was, whose tiger was it?
Mike Tyson.
Go figure. Mike Tyson's tiger. Here we are, a little town of Notre Dame de Luce on the banks of the Lève River. Tomorrow Jeff and I, we're heading down, we're meeting Matt at about 8 o'clock by the statue in the little village there, and then we're heading up to the property because today we had a real problem finding it. We're going to be looking for spinel, geology of the area. We've got a metagabbro with lenses of anorthite and pyroxenite, and through all of that there are veins of calcite. We're going to find the spinel at the intersections between the metagabbro and the outer edge of the calcite vein. So isomorphous series. Spinel fits within that. Spinel has the magnesium. It's a magnesium Al2O4. Other replacements, in other words, keeping the shape, the form will remain the same, typically an octahedron, and yet the chemical composition will vary slightly. So garnite, which is a zinc Al2O4, is one possibility. Hercinite, which is an iron replacement of the magnesium, and galaxite, that's the manganese end member of the isomorphous series with the spinel. So one of the other things you're finding there in close proximity to spinel is the forsterite. Because it's an olivine, it's going to be one of the first of the minerals to precipitate out of the melt, but the fact that it's entrapped in calcite with the spinel, the calcite being amongst the last of the minerals to solidify, says that those crystals of forsterite would have been bored up from way down below within some magma chamber or whatever, where they've already crystallized a long time prior to the time that the calcite solidified and entrapped both the spinel and the forsterite together. Jeff and I, downtown Notre Dame de Luce, just waiting to meet up with Matt here before we head off to the spinel occurrence. We've got the Lève River behind us. Beautiful, beautiful place in the Gatineaus. This. Just found the pit. We were searching this whole area yesterday. I must have been 20 or 30 feet from it. Here it is. And of course, we got Matt with us here. He's led us into the area.
So what color rock is it actually in? The calcite.
It's in the calcite, eh?
Pinkish calcite.
Okay.
Some of the calcite.
So just a few minutes of scuffling around in the bottom of the trench. Matt's advised us that the calcite vein runs across like this. You can see it on the other side. The pink, good example. So my first decent spinel, you can see the edges are kind of almost looks beveled. It's a modification of the octahedron form. The beveling being the dodecahedron that's influencing the actual form, as they say, of the mineral. Sometimes these isometric crystals fluctuate. For example, a garnet being a good example where it can mix up different forms, and obviously that's the case here as well. And you can see that sort of triangle. That's one face of the octahedron.
Broken.
Oh, that looks like a little larger of a one as well, yeah. And there's a forsterite crystal just on the, it's been broken and it's not a super good quality, but forsterite, yeah, orthorhombic as I say. So when we're saying orthorhombic, we're saying it's kind of the shape of an old matchbox where the axes are all of different lengths. There's a beautiful one, forsterites along with the spinels. There. So just kind of, Jeff and I are kind of digging along the edge of what we think is the natural rock edge, and of course we're finding debris and rubble. This used to be an old mica mine, I believe in 1910 is when they were mining it for mica, and everything, there's a lot of rubble that's been pushed back in, and just in amongst the rubble, this is where we're finding our spinels, in particular right on the edge of the calcite. So yeah, there's the natural face of the rock, and there's also the face on this side. We've got Matt up top digging where he believes there's the primo area. Jeff down below going deep. It's a slightly larger one. Matt says you can often find them up to 2 centimeters in reasonable quality, and 5 centimeters in poor quality. Kind of one of the cool things is when this stuff, as it's forming, because it's in the isometric system, it forms often without much tension on the crystal itself. It's growing equally in all directions. As a result, there will be no tension cracks. If you were to get a clear one and to be able to see the inclusions, they wouldn't be lined up in a tension crack like cutting across the planes. They'd more likely be parallel to the crystal face in a plane. You know, sort of like a ghost quartz crystal, you know, that mirrors the outer crystal shape. There's a beautiful spinel on a forsterite. That's found in Jeff's pit there. Where'd you find it, Jeff? In the wall?
Chipping it out of this rock.
Right at the calcite layer?
Obviously.
Mm-hmm. We're running out of energy. Matt has made a big excavation going down and underneath there. Jeff has found some amazing stuff inside rocks that he's been breaking, basically calcite, so I started breaking calcite. I certainly haven't had the success levels that he has had. Was it that you were being particular with the kind of rock, or what?
No, not really. Looking for the calcite.
Yeah, okay, so basically, as has been pointed out by Matt, if you're looking at a rock that has a few nice crystals, and it's calcite, basically where the calcite meets the rock behind is often a place you want to go for. So that's what I've been doing. I've been breaking the calcite and the rock, and I found a bunch of interesting stuff. But this is basically it. There's a few really nice interesting faces of spinel. So this is one of my favorites here. It's very small, but the face has got really cool triangular growths on the face of it, and again you can see the close-up here that I've just taken. Oh, that's a beauty, man. And that's just sitting right on top of the calcite, eh? That's it. We're done for the day. tired. We've found some really nice forsterite, some really beautiful spinels. Definitely the lesson here, it's down at the bottom. You can find some pretty good specimens also in the rubble, but typically it's always associated with the calcite. Luck of the draw, I guess.